Hi, welcome to another episode of Eccentric Cosmos. Today we explore one of the most famous thought experiments in the history of physics, Schrödinger's cat. Have you ever heard of Schrödinger's cat? It's a thought experiment in quantum mechanics that asks us to consider the bizarre nature of the quantum world. The experiment was first proposed by physicist Erwin Schrödinger in 1935. The experiment goes like this: imagine that you have a cat inside a box along with a radioactive material, a Geiger counter, and a small flask of poison. The poison will be released if the Geiger counter detects the decay of the radioactive material. But the decay is a random event that could happen at any moment. Schrödinger proposed that the cat inside the box is in a superposition of states. It is both alive and dead at the same time, until we open the box and observe it. This is because the decay of the radioactive material triggers a quantum event that affects the entire system, including the cat. Now, according to the principles of quantum mechanics, it means that the cat is both alive and dead at the same time until we make an observation. This idea is based on the concept of wave-particle duality, which says that particles can exist in multiple states simultaneously. But when we observe them, they collapse into one definite state. So, what happens when we open the box? According to quantum mechanics, the act of observation collapses the wave function of the system and forces it to take on a definite state. In other words, when we open the box, we force the cat to be either alive or dead, but not both. This is where things get really interesting. Quantum mechanics also tells us that a system can exist in multiple states simultaneously, including quantum computers. This means that a quantum computer can perform calculations in parallel in all possible states, leading to an exponential speed-up. However, this raises the question of what happens when we observe the output of a quantum computer. If observation collapses the wave function, how do we know that the answer we get is the correct one? So, what can we take away from Schrödinger's cat experiment? It teaches us that the quantum world is full of surprises and challenges our classical understanding of reality. It also shows us that the act of observation has a profound impact on the quantum world, and raises fundamental questions about the nature of reality itself. This is still an open question in quantum mechanics, and it has led to many interpretations of the theory, such as the Copenhagen interpretation, the many-worlds interpretation, and the pilot wave theory. Each of these interpretations offers a different way of understanding the role of observation in quantum mechanics, and the nature of reality itself. But the problem remains unresolved to this day. Thanks for watching, and we hope this video has shed some light on the fascinating world of quantum mechanics. Please subscribe to our channel, Eccentric Cosmos, for more science content.